Hey, I just want to go through the quiz and just kind of a quick, maybe extra helpful data example that can be useful for the homework. And then I can talk about some of the homework questions again in detail. So just as a reminder, I do have office hours tomorrow from 2 to 4. There should be a link. If I'm not in there right away, I get a notification on the email that I have somebody in there, and I'll be in shortly. So if you join the room and nobody's in, just hold tight and I'll be in the next minute or so. Okay, so I just wanted to kind of walk through the quiz. Okay, so just walking through the quiz, this is the first question is what's the solution to this? Let's see, let me go to the first question. The first question is what's the solution here, xi squared for this set of data from 1 to 5. So 1 squared, right, is 1, 3 squared is 9, 7 squared is 49, 2 squared is 4, and 1 squared is 1. So all I have to do here is have to add them up. So it'd be 1 plus 9 plus 49 plus 4 plus 1, which is equal to, these are 50, 50, and then collectively these are 14. So 50 plus 14 is 64 is the answer. Okay. Next question. What is the 0.2 quantile here of this sample data? So the 0.2 quantile is the data point, right, where at least 20% of the data, the first data point, where at least 20% of the data is below or equal to that value. So if I'm sort this in order, maybe that's the best way to think about it, is I can come here and I can sort it in order. So in order, I have, right, a 1 again, a 2, a 3, and a 7. So I have 5 total values. If I go to 1 right here, at this point, 2 out of the 5 values have already happened, which is equal to 40%. And 40% is bigger than 20%. And this is the first data point where that happens, right? Because if I use a 0.5, for example, if I use a quantile here, then none of the values are to the left of that. So the quantile here, the 0.25 quantile is 1. Okay, third problem. This is what is the mean of the data. So here you just add it up and average it. So the addition, right, is 7 plus 3 is 10, plus 4, that'd be 14. So it's 14 over 5 is the answer, is the mean of this data. Okay, this question, I had some people, maybe misunderstand, but if I'm just summing the indicator here, then this sum at most is going to be 5, and at worst it's going to be a 0. So if this condition doesn't have it all hold at all, it could be a 0. If it holds ones, it'd be a 1. 2, it'd be a 2. 3, it'd be a 3. 4 would be a 4. And if it happens all 5 times, it'd be a 5. So I can go back and look at all this. What is xi squared for 1? If xi is 1, is 1 plus 2xi, that's 3. Okay, that's not bigger than 10. Right, so the first thing I'll do is I can come here and square everything. So I've got my numbers 1, 3, 7, 2, and 1. And I can say xi squared plus 2xi equals, here we're going to have, this would be 1 plus 2, that's 3. This is equal to 9 plus 6, that's 15. This is equal to 49, because 7 squared is 49, plus 14, which is 63. This is 2 squared, which is 4, plus 2 times 2, which is also 4. This is 8. And then this is 3 again. So the indicator function, we come through and check, is it bigger than 10? Question mark. Here, the answer is no. So this indicator is 0. Here, the answer is yes, 15 is bigger than 10. Here, the answer is yes, 63 is bigger than 10. Here, the answer is no, 8 is not bigger than 10. And here, the answer is also no, 8 is not bigger than 10. So the total answer, the sum is 2. Okay, last question is similar. This is what's the median? So the median will be the first data point where 50% of the data at least has happened. So we can look at it, right? I can sort everything again in order. So in order, I've got 1, 1, 1, 2, 3, and 7. So here when I was at 1, this is 40% of the data. So 2 out of 5 has happened here at this point. If I could pick a median here of 2, exactly 2, then now 3 out of 5 of the data points have happened. And this is bigger than 50%. It's bigger than 1/2. So this is my median is 2. All right. So let's just go kind of play around with an example data set. This is just one I've been working with today. I can just give you kind of a little more incentive on how to work through this. Let me also go to the main page into the assignment so we can kind of look and talk through it. So I have this data set that I've already kind of been working with today. I'm going to kind of strip this file back. I could say like, labs process 3. I'll say scratch 6.1. Okay, and I can upload this data too. It's fine. It doesn't really mean anything. So this data, I have this in my labs cutoff file. Let me show you what it looks like overall. So if I go to work, labs cutoffs, I have lab process 3. That's this data here. So this is just a big basic data file. And what it does is it looks at patients will get a total knee replacement or a total hip replacement. And then it follows them forward for the next 90 days to see if they have any kind of complications. So they could get an infection, they could get deep vein thrombosis, whatever. Now I also have lab values on these patients, not everyone. So each row is a patient. So like this patient, the first patient had a BUN of 22, calcium of level of 9.7, creatinine level of 0.3, glucose is 70, et cetera. So I have all these values. And then I also have different like CCI, what's their CCI, how long did they stay, what's their gender, what's their smoking status, did they use alcohol, what's their age, all that kind of stuff. So let's just kind of play around with this data a little bit. The goal of this is just to maybe kind of give you, again, some intuition on how to do this. So let's actually save this here in my BSPH file, and I could say like example 6.1, and I want to go to this folder. So I want to identify it. So let's go back to my R, and I want to find this folder. So what I usually do is I'll come here and I'll say, okay, LSU, this is my class, right? So wherever you save this file, it needs to go there. Example 6.1, properties. Okay, here's my location. So I'm going to copy paste this. Again, the first thing to do anytime you get a new data set is just read in the data set. So this is my file here. ESPH program, LSU teaching. So the first thing I'm going to do is read it in, and the name of the file is example 6.1. So I might copy paste the actual title up here, and it is a .csv file. So example 6.1, and this is going to read in the data. That's the first thing I always do. So I can look at this data now that I have it read in. I could say, okay, head of data. This is just going to kind of show me what it all looks like. I can see the names here. I can see a lot of data filled in, names of data. Okay, these are my names. So let's just kind of play around with. So maybe I've got albumin. I want to look at albumin. Okay, does albumin differ by gender? Things like that. So first thing I might do is I might say, okay, let's look at albumin. So I might say summary, data, albumin. Okay, so now I'm indexing the albumin data. I can see right in this data set, this is my minimum, this is my first quantile, this is my median, this is my mean, this is my third quantile, this is my max, this is the number of NAs that I have here. If I do a sum here or mean here, just to get that by itself, I'm going to get a missing value. The reason for that is I have missing values. So what the summary function does is just kind of ignores the missing values, but I can pass this into means easily, right? I can say albumin, na.rm equals true. And this will give me now the same number as here. So let's say I want to get it by gender. I can look at table data gender. These are, again, self-identified genders. I have, I think, sex maybe. Okay, so I have sex here. I also have smoking status, smoking. So maybe let's do it by smoking. Okay, does albumin differ by smoking status? So I could say, you know, does mean albumin differ by smoking? Question mark. I could say mean of data albumin. And then I need to index the smoking group only. So I'm going to put in brackets data smoking equals 1. I need to do na.rm equals true. This is for the smokers, 3.7. For the non-smokers, all I need to do is change this to a 0. So this 3.73. So the means are actually pretty close to each other. I can look at standard deviations and stuff like that if I want. SD, oh, here's SD of 1. I can also plot these things. So I can plot, you know, for example, I can say, okay, histogram of data albumin, and I only want the smokers, smoking equals 1, and I'll do breaks equals 50. Here, this is my histogram. It's giving me a little bug. Sometimes that happens. It's just that the figure margins aren't wide enough. If you fix them up, it should work. I don't know why it's fighting me. There it is. I think it's because I'm using a smaller scale. So here's my plot. These are for the albumin levels for the smokers, right? So I can see this kind of central tendency over here, and I can see this kind of shifted across. If I want to make this title a little nicer, you know, I could say main equals albumin for smokers. And I could say xlab equals albumin or frequency. And oh, X label is for the X label albumin. And then now I have a nicer looking plot. So let's say you can see here, right? Everybody noticed that there's a lot of albumin values between 3 and 4. Maybe I want to know what % of the data falls in that range. So what I can do is create an indicator variable. Now, just to show you what that looks like first, I can say data albumin bigger than 3. So this is giving me an indicator, yes, no, true, false, which is a 1 and a 0. Is this thing bigger than 3? You can see this here. If it's NA, that just means there is no albumin value. Let me come down here a little bit so we can all see our, I can table this thing, right? So this is going to be the number of albumins bigger than 3. So 1500 bigger than 3, 1700 smaller than 3. I can also do the same thing for like less than 4. So if I want to get an indicator together being between 3 and between 4, I just need to multiply these things together. So I say data albumin less than 4. And I can table this information. I can figure out how many of these happen. So this is the table. So I can see here that 8,000 values are between 3 and 4, 7,000 are not. And I can take means of this too. So what %? If I'm going to do a mean here, I need to actually do a na.rm equals true. This. So for everybody, 53% of the data points, the patients here had an albumin level between 3 and 4. If I want to get this for the smokers only or by smoking, then I can just index these here with a data smoking equals 1. I need to index a second one as well. Data smoking equals 1. Here, this will run both of them. 52% of the smokers had an albumin in this level, and then I can do non-smokers, just change it to zeros. I need to do both of them, or else they'll be different lengths, and that's 54%. I could also do something like maybe I want to do a scatter plot of 2 different lab values. So let's look at the names of my labs, names data. So I have, you know, a whole bunch of data sets here, but maybe I want to look at the relationship between albumin and let's say calcium. Okay, so I can do that. I can say plot data calcium, data albumin, and this is just kind of a basic plot. I'll add things later. You can see this is my plot. There's, I guess, some kind of increasing trend, right? It looks like as calcium increases, so does albumin. I can make my labels a little nicer. I can say xlab equals calcium, ylab equals albumin. And for my main title, I can say calcium and albumin relationship. And now I have a nice little plot. Now, if I wanted to do this, I can do this for smokers and non-smokers as well, right? So how do I do this for smokers? Well, now I have to index them by smoking. So I can say data smoking equals 1. I just need to add this little bracket here. Data smoking equals 1. And I can say here smokers. So now I have this plot for smokers only. And I can also do this plot for non-smokers pretty easily. I just have to change this to a 0, and I change this to a 0, and I'll just change the title here. So now it's non-smokers. And now I have a plot here of non-smokers. So I can kind of look at these together. If I want, I can add those points to the same line by using the points command instead. So just to show you what that would look like, I can say, points. And here I want to add the smokers back since I'm looking at a plot of the non-smokers. And let's make the color of this is red, just so it's easy to see. And you can see now I've added these extra points to the line. So it's non-smokers is black, smokers is red, but you can see a nice little scatter plot here. So let's go look at the homework assignment. I think that's kind of like what we just walked through with smoking status. You're going to use race as a variable for that. Okay, so the first thing to do is calculate what's the percent, how many heart disease patients are in the data, and what's the percent who have the disease. So as an example, using smoking, right? I can look at some data smoking. So I can see that collectively, I can do table too, just to look at this in a different way. Collectively, 17,474 of these patients were smokers. So you're going to do the same thing with heart disease. And if I want to know what percentage this is, I can just say mean. Now, if I have a variable with missing data, then I'm going to need to pass a na.rm equals true to this. So I can see, what does this say? If the mean is 0.39, that means 39%. If I want to multiply this by 100, I can, times 100. So 39.57% of the patients are smokers. And you can see, right, that's just the same number, 17,17474 divided by this sum together. The mean and standard deviation of BMI in each racial group, right? We just did that with albumin as this example. So I could say, as an example, I say this like problem. And I'll upload all of these for you to use too. So that's the BMI. So we did the albumin, right? Then you're going to do some random variable generation using the function rnorm. So remember the function rnorm. If you want to look at the help rnorm. Here's the information. So rnorm of, you see how it says n is how many sample sizes do I want? So maybe I want 100. Maybe you want a mean of 1 and a standard deviation of 2. So now I have my random data points. But what you're going to do is you're going to randomly generate those data points, and then you're going to calculate this sum. So you're going to show me the 10 random variables, and you're going to actually calculate this sum in R. So you're going to have to create indicator variables and things like that. What's the proportion of patients that have a BMI between 30 and 35? So I'll just come give everybody a little, kicker down here on how we do this. This is this problem right here. This is like number 4. So we did it for albumin. It said you're going to do this for BMI and different levels here. What proportion of patients in each heart disease group have an age below 30? So that's just looking at right in the smoking group as an example. So I can use albumin. So this would be problem 5. As an example, I could say, okay, what percent of patients in smoking groups have albumin below 3? Question mark. And I can just say, okay, that's mean data albumin, and I want data smoking equals 0. I need to do an na.rm equals true. Why? Because you'll see I get an na here. So that's just because I have some missing values. And I think the reason R does that is they want to just make sure you're aware, hey, they're missing values in this data frame. So this is the percent. This is actually, so if I'm less than 3, I need to pass this less than 3. You can always run parts of your code, right? This should turn it into trues and falses. You can see it does. So the percent that have less than 3, it's 7% in the non-smoking group. You see that 0.7. And in the smoking group, it is 9%. Plot a histogram of the sodium levels in each heart disease group. So we just plotted some histograms using smoking. So I'll come and add as an example. I'll say this is like number 3. Where is this? This is like number, what's this problem number? 6. And then we have BMI and sodium levels. You want to do it in each heart disease group. You want to use one plot and color the heart disease in red. So this is very much like the problem we just did down here. So that's this here where I added points. And say this is like homework problem 7. Lastly, what's the proportion of patients with BMI levels above 40 who developed heart disease? What's the portion who developed heart disease in the lower group? So here we're just indexing in a little bit different way. I could ask that question in this example here. So I could say this like, what's that, problem 9? Like problem 8. So here, if I want to know what's the proportion of people with albumin less than 3 that are smokers, I can do that in the same way. I could say mean data smoking. Now I just need to index data albumin is less than 3. Okay, so this will be the percentage of smokers. It's an NA, right? Because I have some missing values. RM equals true. So here I get 42% of those with albumin less than 3 are smokers compared to, if I go above here, this would be 36%. Let's say I want non-smokers. Well, I can do that by just transforming these into an indicator of equal to 0. So that would be 57%. You can see, right, that's the same. That's just the opposite of these two added up, 42 plus 57%. So that's what you're going to do with heart disease. Just to show you, right, this text here, this is totally equivalent to just turning this into another indicator like this. So you see these two are the same. Okay, well, I hope this is helpful. I'll upload all this material, and you know, I'll reach out. I'll reach out via email and just kind of ping everybody that this is up there. Some of you have expressed interest in attending office hours tomorrow. Please come. And if you have any questions in the meantime, feel free to watch. But I do think watching this video should be helpful as far as going through the assignment.